Good morning. This recording is for Algebra 1, Chapter 6, Lesson 4, Applications of Linear Systems. Basically, we're going to take everything we've learned in the last 3 lessons and apply it to word problems. Yay! So there's always the steadfast graphing method, which I don't recommend doing unless you have some type of graphing app or graphing calculator, because it can be a real pain in the bottom if you're trying to graph really large numbers or even really tiny numbers. And some of these problems, though most of the answers are going to be integers, are not going to be something that you're going to want to have to graph without, really precise tools like a ruler. And some of you guys are, whatever. Okay, substitution and elimination. Remember, substitution is where you get one variable by itself, set what that variable is equal to, plug it into the variable for the other equation, and then solve for the remaining variable. Elimination, you cancel out an entire variable. Sometimes you have to multiply, sometimes you have to multiply both of the equations so that something will eliminate out, but you guys know how to do that. Alright, so first problem. Actually, most of the problems in this chapter you have done before using a different method. You have used a single variable form of solving this. In my opinion, it's much more easier to think about it as a 2-variable system, just because there's usually 2 things going on. Okay, first problem. Suppose you combine ingots of 25% copper by weight alloy and 50% copper by weight alloy to create 40 kilograms of 45% copper alloy. So an alloy is basically like 2 metals melted together. In this case, we only care about the copper, which is one of the metals that is in the alloy. And again, an alloy has multiple metals in it. In this case, we're only caring about the copper that's in there. There could be 4, 5, 10 billions of other metals in there. But we only care about that one of the ingots is 25% copper, so a fourth of this by weight is copper, and another one which is 50% by copper. 50% copper. But we need to make another ingot, another alloy that is 40 kilograms and 45% copper alloy. So how many kilograms of each ingot do we need? Well, let's go ahead and make an equation. So the first equation is going to be the grams of each alloy. Grams of the 25% copper ingot and grams of the 50% ingot. How much of each piece we got to knock off so we can melt it together so that we can make our product that we want. So we're going to make A, the grams of alloy that is 25% copper, B, the grams of the alloy that is 50% copper, which leads me to my first equation, which is A plus B equals 40. I need to take some kilograms of A, some kilograms of B, melt them together to get 40 total kilograms. All right. Equation 2 is the mass of copper, percentage times the kilograms equals the total amount of copper in that alloy block that I've cut off of my total to figure out how much I need, which leads me to the equation 0.25A, so that's the percentage of A times the percentage of B, the percentage of A times the number of kilograms of A plus the percentage of B times the number of kilograms of B. All right, and this is supposed to be kilograms. Kilograms, there we go. All right, equals the 45% of the 40 kilograms needed of the final. So now that I have 2 equations and 2 variables, I can solve using a system of linear equations. And I'm going to go ahead and use substitution, and I'm going to solve equation A for B. I subtracted A on both sides, B equals 40 minus A. Hey, this should look really familiar. Back to like chapter 2, guys. This is almost a review, but it's solving the same type of problems with 2 variables instead of 1. Plug 40 minus A in for B, and I'm going to get 0.25A plus 0.5 times 40 minus A equals 0.45 times 40. I need to distribute, and I'm going to get 0.25A plus 20 minus 0.5A equals 18. I'm going to simplify a little, subtracting my like terms. 0.25A minus 0.5A is 0.25A. And then I'm going to solve for A. Minus 20 on both sides gives you minus 2.5 or negative 2.5A equals negative 2. Solve for A. A equals 8. And if you remember all the way up there, that A plus B equals 40, I can figure out what B is by subtracting A on both sides. B equals 32, which means I need 8 grams or kilograms. We're dealing in kilos here, kilograms of the 25% alloy and 32 grams of the 50% alloy to get a final alloy that is 40 kilograms total weight and 45% copper inside of that thing. Okay? All right. Breaking even. Breaking even. The break-even point in business is the point at which the income equals the expenses. Basically, you're not making any profit. And if you can see on the graph over there on the right, the yellow side of the graph is the profit margin, basically where your income has exceeded your expenses. That's when you're making money. But the break-even point, on the white side, by the way, is when you're not making any money. The income is over the expenses are over the income. Therefore, you haven't made any money, or at least enough to even cover what you've already spent. The break-even point is where the income and the expenses hit. That means that is where the amount of money you've spent equals the amount of money you've brought in. So anything that you've spent on this venture, you've now officially made back at that exact point. And then everything past that point is the profit. So we want to know what the break-even point is for several situations. All right, suppose a club publishes a newsletter. Expenses are 90 cents for printing and mailing each copy, plus $600 total for research and writing. The price of the newsletter is $1.50 per copy. How many copies of the newsletter must the club sell to break even? All right, so this one's a little confusing because you have the same variable in this equation, meaning two different things. And I'll talk about that in just a second. So the first equation is the expenses per copy. How much does it cost to make a certain amount of copies for this newsletter? All right, so X is going to be the number of copies of the newsletter. And here, you see how Y equals income, when profit, money, or not profit, excuse me, money income, but it also equals money profit. And actually, it doesn't even equal money profit. It equals income and expenses. Oops, wrong one. Expenses. Okay, that equals two different things. The only thing is because we want to break even, it's where the income equals the expenses. So Y equals Y because Y is both income and expenses because they're the same amount. Now, if you were talking about profit, the income should be more than the expenses, but since we're breaking even, we want them to be exactly the same. Exactly the same. All right, so equation 1, back there near the bottom, is Y equals 0.9x plus 600. 0.9 is the 90 cents for printing and mailing, and the 600 is how much we have to spend on research and writing as a total. Okay, and so that's going to lead us to our expenses, which is Y. Okay, now let's talk about equation 2, which is the income per copy. How much money are you bringing in for selling your newsletter? Well, that's $1.50 per copy. And so X is the number of copies, so $1.50 times the number of copies tells you the number of income. But since income and expenses are equal in a break-even situation, we can use the substitution method to solve this problem. All right, so we're going to substitution. Profit equals expenses when breaking even. Therefore, the amount we spend on making it should equal how much money we get back in when people buy it. All right, so there's the first equation, and there's the second equation right there. Okay, all right, so let's go ahead and solve for X. How many copies of the newsletter do we need? So we're going to minus 0.9x on both sides, and we're going to get 600 equals 0.6x. We're going to solve for X. X equals 1,000. So X being 1,000 means we need to we need to make and sell 1,000 copies of our newsletter. But the thing is once we know our newsletter, even though the question doesn't ask it, how much are our expenses and our income if we produce 1,000 newsletters? Well, we can plug it back in. And we're going to find out that it costs $1,500 to make 1,000 newsletters. All right, which means we also need to sell 1,000 newsletters to break even. All right, next type of problem. Back to lesson 2.5, which is a rate times distance problems using one variable. Instead, for this lesson, we're going to use two variables, and a two-variable system can also be used to solve these types of problems. All right, but there's some important things you need to know about the United States. The steady west to east winds across the United States act as tailwinds for planes traveling from east to west. Tailwinds increase ground speed. All right? Tailwinds increase ground speed, which means they're going to help the plane go faster even though it's maintaining its constant speed. All right? It's kind of like going downhill in a car. You don't have to give the car as much gas to go downhill because the downhill forces are going to help you go faster with less gas. In this case, for the plane can go faster with less of an average speed, or maintain the speed, or the ground speed in this case, when they have a tailwind. Now, the opposite is true for planes that are traveling from east to west, because when we have a headwind, because the wind is hitting the head of the plane, the front of the plane, and this is going to decrease the plane's ground speed, because now the plane is having to fight the wind to keep its speed. It's the same thing when you're going uphill in a car. You have to give the car more gas so that you can go up the hill but still maintain the speed you were going before you got to that hill, if you want to keep your speed constant, obviously. All right, so you need to know that about the United States. The other thing you need to know about the United States is general idea where things are located. If you don't know that Sacramento is on the west side of the United States and Chicago is east of Sacramento, or vice versa, Sacramento is west of Chicago, you're going to have a hard time with these problems. So try to remember to visualize the United States. Okay, so very quickly, you need to understand that the airspeed plus or minus the wind speed, and that's actually supposed to be a minus. That's a minus. There we go. So the ground airspeed plus the wind speed equals the ground speed if you are heading from west to east. If you're heading from east to west, your airspeed minus your wind speed is your ground speed. Okay, and that again goes back to the car. The east to west would be going downhill because the wind speed is helping the plane go faster, whereas going east to west would be going uphill because the wind speed is now fighting your airspeed. So ground speed of a west to east plane should be faster or higher than the ground speed of an east to west airplane. Okay, so here's our problem. A plane takes about 4.5 hours to fly 1,800 miles from Chicago to Sacramento. At the same time, another plane flies from Sacramento to Chicago. So they're going opposite directions. This plane travels with the same air, this plane travels with the same average airspeed, but the flight to Chicago takes 3.75 hours. All right? Because the slower plane has a headwind and the faster plane, faster I mean takes less time to fly, is got a tailwind. So they've got some stuff either hindering or helping them. We need to find the average airspeed of the two planes. So, when the pilot's in the cockpit and they say, all right, I'm going to set my speed, because they have like cruise control on airplanes like they do on cars. They say, all right, we're going to be traveling at 300 miles per hour. The only thing is if you're flying west to east, because you have a tailwind, you're really going to be flying faster than that because you have something helping you out. Whereas the plane going from Chicago to Sacramento has a headwind, and the headwind is going to, even though they're flying at 300 miles per hour, the same, or whatever it is that I said for the other plane, is going to be slower because they are now having to fight the wind instead of having the wind help them. Okay? All right, so let's go solve this problem. A is going to be the airspeed, what the pilot sets the airspeed at, like 300 miles per hour, whatever standard for an airplane, I don't know. But the wind speed is either going to help the plane or hinder the plane. It's either going to be a plus situation or a minus situation. So let's go ahead and write our equations. Okay, so the tailwind, the rate is going to be helping it. in the headwind, the rate is going to be hindered by the wind speed, okay? And again, it's rate times time equals distance. All right, so here we have our equation. Sacramento to Chicago, we have a positive for the tailwind. From Chicago to Sacramento, we have a negative headwind because the headwind is hindering the plane from doing what it needs to do. The plus sign always gets the lower time because obviously the tailwind helped and sped up the plane, whereas the headwind, slowing the plane down, makes the plane take longer to go the same distance. All right, so how do you solve this problem? Well, you're going to use elimination, but you have to get the A's and W's completely alone on one side of the equation before you can do elimination. So we're going to divide the time on both sides to figure out what AW equals. Okay, so Sacramento to Chicago is A plus W equals 480, and Chicago to Sacramento is A minus W equals 400. So let's go ahead and line these up. We're going to do elimination. The W's are going to cancel out, leaving me 2A plus 0 equals 880, because 480 plus 400 is 880. We're going to divide by 2, and we're going to get A equals 440. And if we plug 440 back into the equation, we're going to get W equals 40. So what does this mean? It means that A equals 440, which means the airspeed of both planes was 440 miles per hour. So basically, the two pilots got into their respective planes, one in Sacramento, one in Chicago. They take off, and they both set their airplanes to 440 miles per hour. Now, the one going from Sacramento to Chicago has a tailwind of 40 miles per hour, helping out the plane. So instead of traveling just 440 miles in 1 hour, the plane going from Sacramento to Chicago is really going 480 miles per hour because the tailwind has helped them go that much faster. Now, the plane that took off from Chicago heading to Sacramento is really only flying at 400 miles per hour because the headwind is fighting that plane 40 miles per hour and decreasing its speed, its ground speed. Okay, I think I have beaten this horse to the point of no return. That's a bad analogy, but hey, you know what? We're done. I hope you get this. I'm recording this the day before Thanksgiving break, so if you're watching this before Thanksgiving break, I hope you have a good Thanksgiving break. Bye, guys.